Thanks for joining this talk where I'll be sharing our experience with Apache Ignite. Before we dive in quickly, let's mention who we are. We are Cardano, purpose-built risk and investment specialist. You can find more about us on our website. Previously, I shared our story with the Ignite community about how we built our Apache Ignite powered analytics platform and how we were using it. If we do a quick recap, the Quantum API, which we name it, is the API that exposes the functionality of our analytics library called Quantum. It's cloud deployed in-memory database and the distributed compute grid. We use C# for development, and Apache Ignite is deployed in embedded mode. So there's our code running alongside each cluster node of Ignite. We perform valuations and sensitivity analysis of financial instruments and derivatives. Those results that we produce are used in hedging and portfolio management decisions, as well as, of course, reporting. So there are various modes of operations, like from batch execution to ad hoc queries. If you look at where we are currently since my last update from, I think, last year's Ignite Summit, now our platform, I can comfortably say that, is the main calculation engine for projects that require quantitative analytics. We get positive feedback from users about the performance and availability of the platform. This next item is quite interesting because we can still maintain the platform with a really small team of quants. I mention quants because what I'm trying to say is this doesn't require any specialist knowledge, really. If you know a little bit of how the cluster works and how the nodes interact with each other, you don't really need to do anything extra special. There are some things you need to be careful about, but we have different solutions for that. I'll get back to that, like the graceful shutdowns, for example. Also, having fast access to market data for using analytics adds a competitive edge to our platform. Whatever you do outside, for example, say you want to roll out your own calculation engine, implement as part of another project, you are faced with a lot of challenges about performance, scalability, availability, and, well, accessing market data is not always nice, where we really store our market data in our cache in our platform. So if we look at the functionality at a high level, okay, this is a platform that does stuff, but what is it? Okay, we support certain instruments at the moment, and this list is quite, actually, there are few flavors of each title here, but also this list is growing. Recently, we are adding options and many flavors of options, including basket options. We support interest rate and inflation swaps, index linked and nominal bonds, FX swaps, FX forwards, swaptions. Also, since we manage liabilities and hedge those risks, the liabilities are also supported. You could pick a curve and then, based on that, perform your analytics. We also perform calculation of position values along with key analytics, high-level sensitivities, valuation output. Projections are certain key output items that we generate, but also users can get quite granular, detailed sensitivity analysis where they can be used in hedging decisions or portfolio hedge effectiveness monitoring purposes. If you look at the scale of what Ignite can do and what is possible, we are really using very small scale system where we don't have huge amounts of data. What we need is availability, performance, and ability to scale really quickly when we need to scale our computations. So we have 6 caches with various market information like prices, rates, instrument details, volatilities, and some other information. this is used to eventually produce our analytics. If you look at one of our caches, about 100K data points are always in memory at all times. This is the data cache that we use to build curves and store some historic market data. But then 300K of data points are always in persistence. So this is swapped as required. This 100K is not something that we specify in our code, but it's the memory managed by Ignite through our configuration. Ignite decides, okay, I'm going to hold this much of data based on all the strategies that are specified, this much of data in memory, and then this much will be in persistence, and they will be recovered from persistence wherever it's needed. This is also a very good backup when we need to do a cold start, something crashes, you need to recover back. Persistence is there instantly, you can recover back your previous state. For us, it's much faster to load data from persistence than the primary data sources. There are various reasons. Primary data sources may vary in terms of their technologies and performances, but for us, what this means is it's really much easier to look up the data by key. As long as you know the key, Ignite deals with okay, is it in the memory? Then it loads it instantly. If it's not, checks automatically the persistence. So the read-through is enabled for key lookups. That's quite convenient. Also, when we load data from persistence, it's already in the structure we consume in our code. Therefore, no extra processing is needed. You can directly plug it in, and then our code knows how to deal with that. Then that's ready to consume. Otherwise, if you go to primary data source, there are quite some steps to translate data into the format that we need, because those other data sources are not in our control. It's beyond our access, so we can't really go and change and shape them. So if we look at what we did since we started using Ignite and what has changed since my last presentation, well, this is a bit maybe a special case for us. We moved from native persistence to SQL-backed persistence layer. In the past, I remember in early versions, I think there was a out-of-the-box SQL storage implementation. So you would quickly switch to that, but then this was removed later. I thought, why not give this a go and then see what can we achieve with this, because some of the reasons we were looking for an alternative solution was not that native persistence was ideal, but we had some problems. One of them was, okay, it looked like native persistence used some extra resources to manage, synchronize, and rebalance the data. We also seem to be preventing data corruption issues, nodes going out of sync, and baseline topology issues are prevented. When I talk about issues here, I don't mean that, hey, you'll have these issues. These are the issues with the technology. It's not. These issues will happen if you don't honor or respect your cluster as a cluster. If you don't do graceful shutdowns, you will miss certain opportunities. Your data will likely go out of sync when you just shut it down. If your coordinator goes out of cluster, gets killed, and then you get quite frequent topology changes, then you'll have a lot of issues. But then these are all anti-patterns. However, our infrastructure is kind of designed that way. It's not, since being cloud deployed, every pod in our Kubernetes cluster is seen as an individual application. So they come in and out, they are killed due to certain events. We have even a system similar to Chaos Monkey, which it randomly picks a production pod, kills it, and then expects it to come back to provide resilience. So this doesn't go very well with native persistence, because if you don't honor certain needs of the cluster, then you'll get well, issues that's expected. So we wanted to solve these in a different way by implementing an SQL store where we don't need to synchronize data or make sure that we have to have graceful shutdowns. Ignite provides this iCache store interface by just implementing that in C#. I think there's an equivalent one. Well, there's an equivalent one in Java and probably other languages as well. We were able to easily implement this, but then this needed some special attention. I'll get to that. This works much better for our setup. Then we can actually see what is stored, inspect the data, do some external work on it, because this is now in rather than in a format that we can't really navigate. It's in an SQL database. The special attention is, well, if you really take any storage request and naively send this to your SQL server, you may easily overload your SQL server with lots of queries. You need to be quite efficient in how you process those storage requests. Depending on the amount of data, quite likely you might cause problems with your SQL server. We did this by simply stating every operation in terms of an SQL bulk copy. Then that seemed to perform much faster. I think the SQL bulk copy operation, at least for C#, does some special things in the background such that it performs much better in terms of table blocking, locking, and that kind of stuff. Okay, I think, move on to the next slide. So what are we going to do with this system? If we have a look into the future of our platform, I think we are quite happy. I can confidently say that we are quite happy with what Ignite provides us and how it operates. It doesn't need too much maintenance. It's easy to operate and it's quite performant. I was in the beginning quite skeptical about, okay, what happens with all of these deserialization over and over again, but this turns out to be performing quite well for us. We are looking to add more instruments and capabilities to our framework by supporting more instruments, more market data, and then expanding our capabilities for our users. Also, another concept we want to explore is to extending the cache usage beyond just market data, but higher level objects like curves and volatility surfaces, so that to reduce the need for having raw market data there, but working with higher level objects. Because whenever you try to value an instrument, do some analytics, you may have a position, you may have a trade that you want to value or do some analysis on it, then you need some other piece of key information, which is the market data. But you can't really use raw market data. You need to do some processing to build some curves, bootstrap it, or extract some extra information, or build a volatility surface, then do some interpolations, and you can obtain the usable data. So we are looking to avoid this intermediary processing of the market data and then just storing curves and higher level objects that we can directly plug into our analytics. This way we will avoid quite some extra processing, repeated processing, and then Ignite will easily handle this scenario for us. We are also looking into use of more distributed data structures. I think they are quite useful, especially if your background is not coming from a cluster setting where you work on individual applications. You do something in your application and then it runs. If you run it 5 times, it's happening 5 times, but then there are certain things that you need to synchronize across the cluster, or even having a distributed queue is super useful. I'm not sure if it's at the moment available to C# API, but these things are really good stepping stones to switch from an individual application mindset to a cluster approach. Then you can say, hang on, there is this process, it does this work, but then it should do it only once, or it should be synchronized, or that kind of stuff can easily be handled by either the atomic long, atomic sequence, or if Q was available, that would be good to be able to also use that. I think this is all I wanted to talk about today. Thank you very much for joining this talk. I'm ready for any of your questions. Thanks.
Thank you, Ferda. So, welcome back to the stage.
Thank you.
So we do have a couple of questions for you, and so the one that I have actually first is maybe a little bit more of a use case question than it is about a specific technical. But can you tell us a little bit about how the competitive edge really emerges from faster access to analytics and faster access to market data? What is the importance of getting that information so quickly?
Yeah. Okay. Well, certain calculations scale a lot, as in when you look at a single instrument valuation, it's a quick process done in milliseconds. If you start going into sensitivity calculations, then you are bounded by the number of nodes on your curve in question that you are calculating your sensitivity against. Then if you say, which we do, go with a numerical approach where you bump your curve, evaluate and calculate the sensitivities for each node point, then when you scale this up to a portfolio size, this may take forever if you done it in a standard local deployed application, because you will eventually hit CPU limit, and the way to scale it, okay, wait longer. But there are certain calculations that needs to be done instantly, such that a trading decision needs to be made. Then if that calculation is not ready, you can't say the markets, hang on, wait, I need to wait for a result. So for us, it's quite critical. But also even for batch operations, you would say, okay, I can finish the calculation until the sunrise, but that's generally, batch operations are the places where really large scale calculations are done. And if they aren't done very efficiently, they may not even finish complete until you need them ready. So that still should scale up quite well.
Okay, so a follow-on question then, if the data size that you're using grows significantly, really significantly, is your setup still optimal? Do you have the risk of running into memory limits, for example?
Yes. Okay. Yeah. Well, also, I think in my last Ignite Summit, I mentioned we are using replicated database, so we scale the computation rather than the data at the moment, and we are aware of that. But we will switch to a different mode where we will using the affinity function and partition data. We will partition our data. So short answer, our current setup is not optimal for any scenario, but we are well prepared thanks to Ignite for those scenarios, because we will be able to easily switch to a partition setup where we will distribute and partition our data and cluster and also computations. So yeah.
Got you. So then one final question. If you had a wish list, which distributed data structure would be at the top of your wish list if they were available via the C# API? What value would that bring?
Okay. I would say Q, because that would do two things. It will allow me to synchronize certain tasks. At the moment, for example, we use a singleton service to do similar sort of stuff, but if Q was available, that would help quite a lot. Also, I'm looking at set as well. If that was available, that would be also nice. But yeah, these are first and second items on my list, I would say.
Okay, noted. Great. All right. Well, Ferda, thank you once again for joining us. I think that's all we
Yeah.
have time for now.
Okay. Thank you very much for
So
having
I
me.
hope
And
you'll stick around and enjoy the rest of the summit. And of course,
course.
we hope to be hearing from you in future summits.
Okay. Yeah, my pleasure. Thank you very much.